As was mentioned in the description that was published, obviously you need to be somewhat familiar with either Jupyter Notebooks or JupyterLab. I myself have only used Jupyter Notebook for years, so just in case you were like me and only use Jupyter Notebook, this is JupyterLab. You have a panel over here that can be opened and closed, has a file browser. I can, for example, open up a notebook over here. I look at the notebook. I have these various tabs that can be moved around. We can open up multiple notebooks. We can run other things over here. This part here is called the command palette, which we'll talk about a little bit as we use it. This can be expanded, can be closed, like that, and so forth. So that's JupyterLab. And obviously Jupyter Notebook is like this notebook over here. So I'm going to go through the entire tutorial so that you get the big picture, see the whole tutorial. All the various building and compiling and stuff like that, I have screenshots, so it'll go faster. We'll get through it faster. And then when I'm done in about 35 minutes, you can open your laptops and I'll show you. I'll put up a very step-by-step exactly what you need to do to run through the tutorial. Okay? So as I mentioned, this is what JupyterLab looks like. So basically, I'll go through the code. I'll explain the code. I'll demo the code. You can watch. Feel free to ask questions throughout. And then at the end, as I just said, you can code it yourself. These are the prerequisites. You should be familiar with Jupyter Notebooks or JupyterLab. You need to understand classes, objects, inheritance a little bit. And you need to have Miniconda or some version thereof installed on your laptop to be able to do the tutorial. A little bit about the company I work for, Bloomberg. We provide all these services to about a little more than 350,000 financial market professionals, and we provide financial news to the public via television, radio, and online. We have over 21,000 employees. Over 8,000 of them are software engineers. So that's literally more than a third of the company are software engineers, very engineering centric. There's about 4,500 engineers who are involved with Python. At Bloomberg, we contribute to and we use and we sometimes sponsor open source projects, such as this one. And we are hiring. If you're interested, go to bloomberg.com/careers. We're also going to have a booth here tomorrow and the next day if you're interested. And a little bit about me, as was mentioned, I'm an engineer at Bloomberg. I've done a lot of full stack stuff, but I probably spent most of my time doing C and C++ on the server side. About 5 years ago, I started doing a lot of Python and Jupyter Notebooks. I'm a big open source advocate at Bloomberg, pushing for its use and contributions. I'm also the maintainer, as was mentioned, of the NPL finance package within the Matplotlib organization. I was a member of the Chartered Financial Analyst Institute for about 10 years, and I started my career a long time ago in molecular biophysics. So, a little bit of vocabulary before we start the tutorial. An NB extension is the classic notebook extension. These are the extensions for the old Jupyter Notebook. They are being deprecated, this style of making extensions. The new style of extensions is called Lab Extension. They work in JupyterLab, and they also work in Jupyter Notebook version 7 and higher. At Lumino and at JupyterLab are NPM package scopes of TypeScript and JavaScript packages. We'll be using both of these package scopes in the tutorial. A plugin. Plugin is a class that provides the extension functionality in JupyterLab. The beginning of writing any extension is to declare an instance of the plugin class, and then you customize it the way you want for your extension. So now we can define an extension. An extension is a package that can be installed that contains one or more plugins. A token is an instance of the Lumino token class, and it's basically an identifier that identifies a service provided by a plugin. And we'll see tokens also throughout the tutorial. The Lumino package scope has a concept of a command registry, and this is utilized inside the Jupyter front-end application. It has a property called commands, and that is a command registry. It's basically just a list of command names associated with functions, but it's the way that you can set up various functions that can be called anywhere within JupyterLab by accessing the command registry. A widget is basically everything you see on the JupyterLab screen. They're all derived from Lumina widgets, and JLPM stands for the JupyterLab Packaging Manager, which we'll be using in the tutorial. Is basically Jupyter's version of the Yarn Packaging Manager. So the tutorial, I broke it up into about, well, depending how you count, 8 or 10 steps, or 11. We'll just go through it quickly here. So the first step is basically to create a kind of a do-nothing extension from a template. We'll use the templating tool Copier. It's similar to Cookie Cutter, if you're familiar with Cookie Cutter or some of the others. Then we'll actually create a command in the command registry to do something. And then we'll execute that command from the command palette that was one of those side panels that I showed you in JupyterLab. Then we'll modify the command to actually create a widget in the main area of the screen. Then we're going to style the widget. And then we're going to execute it. Then we'll see how we can execute the command from other places within JupyterLab, not just from the command palette, maybe from the menu or from the, we'll do it from the launcher. Then we'll see how we can execute the command with arguments to cause our extension to behave differently in different situations. And finally, we'll create our own sidebar widget, which kind of like the launcher, which will have multiple buttons, and we can launch our widgets in different ways based on the buttons. So to start, excuse me, we have to create a Conda environment. This helps everything to run. We're going to call Conda create. I named my environment JLX for JupyterLab extension. This, I'm not 100% sure if this is necessary, but it's in the documentation to use it, override channels, strict channel priority. We're going to get our code from Conda Forge, our packages from Conda Forge, and we're going to set the no defaults option, meaning if you can't find the code in Conda Forge, don't fall back to any default values. We're going to pull in JupyterLab version 4, Node.js version 18, Git, Copier version 7, and Jinja 2 time is something that Copier needs. It's not used for JupyterLab as far as I know. After you create your Conda environment, you activate it, called Conda activate, and now we're ready to start creating our extension from the template. So the syntax is copier copy, and then the template and the destination. So we're going to call copier copy. Our template is on GitHub, JupyterLab extension template, and I'm naming our extension PYDJLX, stands for PyData JupyterLab extension. So when you run Copier, that Copier, it basically asks you a bunch of questions. What type of extensions do you want to do? We're doing a front-end extension. There's also a server-side extension. You can do a theme. You want to create a different theme for JupyterLab and things like that. So we're going to focus on front-end extension. Ask you for the excuse me, for the extension author's name, email, the package name. This is the name of your extension. You can create both a JavaScript package and a Python package. We're going to do both the same name. No reason not to. This is a good one. Does the extension have user settings? If you want, we're not going to do it today because it's a little more advanced. You can create user settings for your extension so that each user can have their own preferences within your extension. You can also set up a binder example so that someone can just run it within binder. And you can also set up tests. I highly recommend, we're not going to do it today, but I highly recommend if you're doing something for production to actually release to other people, I suggest you set up the regression test. And then you can have a repository, you can specify a repository. This specification here is just for documentation as to what the repository is. It goes into the package. When you run that, it's going to create a bunch of files. Let's take a look at the files it created. So you can see here, it created this directory, PYDJLX. If I cd into that directory or ls what's in that directory, you can see all the standard things that you would normally see that comes with a package. You have your change log, your license, your readme file. I want to focus on a couple of files in here to show what they do. So the first one here is this package.json file. This is the file that defines your package for the packaging manager. If you look inside the package, I'm sorry, what happened here? There we go. If you look inside the package.json file, you'll see it's got the name of the package, version number, description, various other things, some of the things that you typed in before, some files, the license. And down here, there's a section I want to focus on called the scripts. And when you run the JupyterLab Packaging Manager, it has a command called run. You run JLPM space run, and then you can run any of these scripts that are defined in the package.json file. So some of the scripts, we'll be running this build script a lot, and it actually does two things. The first thing it does is runs JLPM build live, which is another script down here. So you can see you can reference other scripts within this script section. And all, excuse me. All this is going to do is a TypeScript compile. With a source map for debugging purposes. And then it's going to do, then the second part of the build is to do a JLPM build lab extension dev, which is a script down here, and that calls Jupyter the lab extension command on Jupyter with the build subcommand for development. So if you page down, there's some more scripts down here. I suggest if you get more involved with this, read through the scripts. There's a lot of neat things here that you can use as tools. The other section I wanted to focus on in this file is this dependency section. This lists all the packages that your extension is dependent upon. And this simple template extension is dependent only on the JupyterLab application itself. We'll see later how we can add other dependencies to this section of the file. Yeah, another file in that directory I want to focus on is, you see, so we're in the PyDJLX directory, and within that there's another directory with the same name. This is where our built extension is going to get put when we build the extension. It goes into this lower level PyDJLX subdirectory. Another file I want to focus on here is the source directory. The source file for your extension is called index.ts, index.typescript. And it looks like this. This is your basic do-nothing extension. So the first thing we do, we're going to import the Jupyter front end. We import Jupyter front end prog learning. We're importing both of those from JupyterLab/application, right? We're dependent on that package. And then here's our plugin that we said. This is the basic extension. You declare a plugin variable of type Jupyter front end plugin. And we're going to set certain properties on this variable. We set an identifier. The identifier is just a unique string within JupyterLab. There is a convention to put a colon in the middle of the identifier, somewhere in the identifier. So you're basically scoping your identifier. You have like a scope on the left and something more specific on the right. A description. Auto start equals true means that when JupyterLab starts up, I want my extension to also start up. What does that mean? How does it start up our extension? What that means is it's going to call our activate function. So here we define an activate function. We're defining it as an anonymous function right here. And JupyterLab will pass in the Jupyter front-end application itself to our activate function so that we can interact with it. So we're accepting it here as a variable called app. And all this extension is doing is it's writing to console.log, JupyterLab extension PyDJLX is activated. That's all it's doing for now. Finally, we export the plugin so the rest of the application can see it. So at this point, if you want, it's a good time to make, you have your simple template extension, and so you could create a Git repository, just git init, git add, dot all the files, and then commit the files, and then from then on, as you make changes, you can make your commits. I'm going to show you at the end, I have a GitHub repository with the tutorial in it, and each step that we're going to go through, I did another commit so that you can diff and see what the diffs are. So the next step to build the project, we have to first install everything that we're dependent upon. And we said we were only dependent on the JupyterLab application itself, but that is dependent on a lot of other things that we're going to see. So JLPM install does not install the extension. It installs what the extension is dependent upon, and it installs it in the extension's working directory where you're coding, so that all those dependencies are there for you to be able to build. So if I run JLPM install, this is what it looks like. You'll see this moving for a while. It's rewriting the page over and over here. All the various packages. Mine took about 20 seconds to run to install those packages. After you run that, if you ls the directory, you're going to see two new files. You're going to see yarn.lock file. This is just a text file that lists all the interdependencies between the various packages. Nothing really in there for you to concern yourself about, but that's what it is. And then this is the important thing. You'll see this node modules directory. That's where all the packages just got installed in that subdirectory. If you look in that directory, I'm just looking at the top 18 files, directories in that directory. These are all the package scopes. You can see here, for example, here's the JupyterLab package scope that we just talked about, the Lumino package scope. There's a total of 436 package scopes that got installed when I ran this. And each one could have anywhere from 1 to 10 or 20 packages. So there's a lot of code that got installed there quickly. If I look inside one of these, for example, the JupyterLab package scope, you see here there are 16 different packages. Here's the application package that we already saw inside the extension, and we're also going to use the applets package, and there'll be some other packages that we'll use later. Let's see. Now that all the sub packages are installed that we depend on, now we run JLPM run build. That's that script that we saw inside the package.json file. When you run that, it looks kind of like this. Down here, you'll see successfully. If it ran successfully, we'll see later what this looks like if an error occurs. Okay, so now we created our template extension, we installed the dependencies, we built the extension. Now we need to install the extension. So before we install, I'm going to show you these two commands. You run JupyterLab extension. We saw that command before. It had a subcommand build. Here we're going to run the subcommand list. This will list all the installed extensions. And at the same time, it will list the directories where it found them. It looks in several different places, and it'll show you where it found the extensions. And you can ls that directory and actually see the extension files installed there. Then we'll do the install. Now you could do pip install. The problem with pip install is that every time we make a code change, you're going to have to install it again. So what we're going to do instead, while we're developing, we'll do JupyterLab extension develop. -- overwrite just overwrites if there was something already installed there, it'll overwrite. And that's going to install it as a symbolic link back to the directory where we're working. So this means that every time we make a code change, it'll automatically be there. You won't have to reinstall. And then we'll run these two commands again to see what changed. So if you run lab extension list, you can see here I had only one extension installed. And here it showed me the directory where that extension was installed. If I ls that directory, I can see the extension down here. There's a directory and all the extension files are in there. So now we run JupyterLab extension develop overwrite. And when we run that, it looks like this. It tells me it's installing, then it tells me it's symlinking. Now when I run the list, I have two extensions installed. So it did install correctly. And if I ls, you can see down here, there's both directories except this one that we just installed as a symbolic link back to where we're doing our work. At this point, you want to test and see if your extension is actually working now that it's installed. So since you're working in one window, so you want to open up another window, activate the same conda environment, and run JupyterLab in the other window. And when it comes up, it looks like this. But remember, all the extension was doing was writing to the console. So what we want to do is we want to come over here, depending on your browser. This is Chrome. If Chrome, you come down to more tools and developer tools. If you click on that, it'll open up the console, and you can see right there it says JupyterLab extension PYDJLX is activated. So the extension's working. It's activated. Of course, it's not doing anything, but it's working. It's being activated. So that was all step 0. That's the hardest step in the whole process. All the other steps we're going to see is just change the code, rebuild, refresh the browser. So the next thing we're going to do, we're going to create a command to actually do something. And again, just code, build, refresh the browser. So here's the code change. We were just writing to the console. We're going to leave that write in just so we can be sure that it's being activated. And so we're going to create a command ID. That's just a string. Again, there is a convention some people follow to put a colon in the string so that you can scope things out in the command registry. And now the command registry is, as I said, it was a property on the Jupyter front-end application, so we're going to call app commands. We're going to call add command. Pass in the command ID and give the command a couple of attributes. We're going to give it a label, hello world. And this is the key to the command, is the execute attribute. We're just going to give it a function called say hello. So this basically, the command registry just associates this command ID with this function. Down here, outside, all this is inside the activate function. Outside of the activate function, we're going to define our say hello function. And all that's going to do, for now, is write to the console log. So run JPM build, refresh JupyterLab browser. Here's the build. It was successful. Here's refreshing the browser. And now when I refresh the browser, not only do I have that it was activated, but I have JLXD says JLX, whatever I wrote in there. I forgot to say one thing, pardon me. So down here in the activate function, I also, on the command registry, I called, it has an execute function, so I can execute the command. Now this normally would not execute the command from within the activate function, but I'm just doing it here for testing purposes, just to make sure my command is working. So coming back to that, so now when we refresh the browser, we see the activate, gives the activate right, and then it calls the command which does its own right. Okay, so that was creating a command. Now we have a command. Now let's execute the command from somewhere else in JupyterLab. We're going to do that from the command palette. That was that part over on the side. Let's see it. So to do that, we're going to import iCommand palette. This is one of these tokens that we're talking about. It's a service provided by another plugin. And we're going to import that from JupyterLab app utils. And then down here, where we're declaring our plugin, we're going to add a new property called requires. And we're going to say that our plugin requires the iCommand palette. It's actually in this context where you would call it a token, a Lumino token. So what that tells JupyterLab is don't just pass the application into my activate function. I want you to also pass in the command palette that I'm saying that I require. So it passes in the command palette. We're going to accept it as a variable named palette. And the rest of the activate function here is the same. It's just writing to the console and it's creating our command. And now down here, we're going to call on palette add item. We're going to give it the command ID that we defined up here. And I'm going to give it a category of anything only because on the command palette, everything is alphabetical and I want it to show up at the top so it'll be easy for us to see. So we run the build, refresh the browser. There's the build, it was successful. Here's refreshing the browser. Now, before I refresh the browser, we had this hello world here. But when I refresh the browser, that disappears because I'm no longer doing it inside the activate function. Remember, that was just for testing purposes. But what I do have here now, over in the command palette, I have this new category called anything, and I see hello world. That was the label that I gave it. And if I click here on hello world, now it says hello world over here. So now I'm actually executing my command from somewhere else in JupyterLab. All right, so now let's make the command actually do something useful besides just writing to the console. We're going to create a widget in the JupyterLab main area. This is the main area here where you see the launcher. It's basically just going to open up a new tab and we'll have something here that's where you can put your notebooks or various other things. We're going to create a widget there. So here's the code for that. Actually, this is the first step in the code for that. All this is showing is our activate function is going to start getting pretty busy. So all I did was I split it out. It's no longer an anonymous function. I simply said activate call underbar activate and then down, whoops, sorry about that. And then down here, I simply defined the function underbar activate. All the code is the same. So there's no change here, except I split out the activate function so it's no longer anonymous. Now, we were importing the command palette. We're going to import widget from Lumino widgets. We're going to import main area widget from JupyterLab app utils. What we're going to do is we're going to derive our own widget from the Lumino widget, and then we're going to instantiate a main area widget, putting our Lumino widget inside of it as the content. So that way, this main area widget will have all the properties of most main area widgets where we can move it around on the screen and all that other stuff that we saw. Excuse me. So here's how we do that. We define a class, hello world widget, extends widget. All we have to do is define a constructor. Our constructor we're going to call the super to call the parent class constructor. Specify an ID for our class. This title label, we're going to give it a label, hello world. And this thing, closable, means that the user, we're going to allow the user, if he clicks the X, that the widget will close. Then I'm just going to use document create element. I'm going to create a body and a header. And for the header text, I'm just going to say hello world from PyData. I'm going to append the heading to the body, and then I append the body to this .node. This .node is this widget itself. Okay, so put the body inside this widget, put the header inside the body. So now we have our class, but we have to use it. So down here, we'll come up to here in a minute. Down here, so our say hello function was just writing to the console. Now we're going to actually instantiate the hello world widget. I'm going to call it content. I'm going to instantiate a main area widget, and I'm passing the content in the hello world widget. Now I need to put that widget on the screen. So I need to interact with the JupyterLab application. So the application, we saw that it has this command registry. It also has a thing called the shell, which is basically the whole everything you see on the application. So on the shell, I'm going to call add, and I'm going to pass in my widget, and I'm going to say put it in the main area. You'll see later in the documentation that this could be main, it could be top, bottom, left, right. There's a couple other things in there. And then I have to activate my widget. This is why we gave the widget an ID. We're going to call activate by ID to activate the widget. Now notice before say hello did not have any arguments. Now I need to pass in the JupyterLab application. So here where I'm doing execute, we'll see later the execute function can only take a certain type of argument. And we'll see what that is later. So the way to get the application into my say hello function is I'm going to create the execute function as an anonymous function that simply calls my say hello function passing in the application. Run the build, refresh the browser. There's the build. And now when I refresh the browser, here's my hello world. When I click there, I get a new widget right here. See, it says hello world from PyData. Okay? And if I want, I can move this around. Right? I can move it around to the side. I can drag it down to the bottom. I can click this again and have another one. Okay, so that's my widget. So now, that was command creates a widget. Now we want to style the widget. We're going to see how styling works in JupyterLab. So we didn't look at this directly before, but in our project directory, there's a subdirectory called style. And in there, there's a file called base.css. These other files you don't need to worry about. They actually just include base.css. If we edit base.css, you'll see it just has a comment in it. It tells you where you can look in the docs for various useful CSS patterns. But all we're going to do is we're going to style the body, make sure it takes up the whole screen, center it, give it a color. We'll style the header, give it a position partway down, left and right is 0, so it'll take off across the whole screen, and I'll increase the font size so it's easier to see. Now notice, I'm styling the body and the header only for a specific CSS class. I made up a CSS class called HWW, which stands for Hello World Widget, because if I didn't do this, I would end up styling all of JupyterLab. And I don't want to do that. I only want to style my widget. So that's why I created this class. However, my widget didn't have a class. So we have to add one line of code to the constructor for our widget. We're going to call this.addClass. We'll pass in that class HWW so that now we're styling our widget. So now, with the styled widget, now when we click Hello World, well, first we have to run the build and refresh. And I've actually done that where I forget to, I'll change the code and forget that I have to run the build and refresh. But you run the build and refresh, and now we have a styled widget. Okay, so now let's see how we can execute the command from somewhere else in JupyterLab. This is the launcher area over here where we can launch notebooks and a console and a terminal and various other things. So to execute the command from the launcher, we're going to import iLauncher, the iLauncher token for JupyterLab Launcher. And down here, I could have said, where I say requires, I command palette, I could have said comma, iLauncher, and it would say I require the launcher also, and it would pass in the launcher. But what we're doing, it turns out that the launcher is itself an extension that anyone could disable. Some people might even have a fork of JupyterLab that doesn't have launcher in it. And let's say I want my extension to work whether or not the launcher is there. If the launcher's there, I'll use the launcher. If it's not there, I still want it to work. So then I can say optional iLauncher. So what this tells JupyterLab is anything that's listed under requires or optional, it's going to get passed into my activate function. But if it's optional and it's not found, it'll pass in null in that position instead. So here's doing that. Here's the activate function. I'm accepting the command palette and accepting launcher as either an iLauncher or a null. And then down here, the rest of the activate function is the same as it was before, creating a command, adding the command to the palette. Now we want to add the command to the launcher, so we call launcher.add. But before we do that, I have to make sure I actually have a launcher. So I'm going to say if launcher, then launcher.add. Put in the command ID. I'm using the category of notebook again, just so I wanted it to be at the top of the screen so it'd be easy to see. Otherwise, if I don't have a launcher, I'm just going to write to the console, iLauncher is not available. Run the build, refresh the browser. And now when we run the build, we see an error. So here on my import, it says it can't find JupyterLab Launcher. So this is a new package that we need to depend on. We don't have it. So what do we do when we have a new package we want to depend on? First, let me show you this. If you look in the JupyterLab node modules directory, you can see all the packages that were there, and the launcher package should be here. It's alphabetical, and it should be between doc registry and MD format. It's clearly not there. So how do we add it? We call JLPM add to add a package. So to do that, we're going to call JLPM add, and then the package name. It looks kind of like this. You can see it looked very similar to when we did the install. It's basically installing our package. And now, if you look in that directory, now you can see the launcher. It got installed. Now, notice also if I run git status, package.json file has been modified. So what that JLPM add did, it not only installed the launcher, it went into the package.json file and it added the dependency there. Okay, so now, so this is just summarizing what I just said. It installs it and it adds the package.json file, adding the dependency. Run the build, refresh the browser, the build succeeds this time. And now, here in the launcher, we have another button right here that says Hello World. And if I click that button, I get my widget. And if I click over here on the command palette, I get another widget. So now I can create my widget from different places. Okay, so now, what if I wanted to know where my command was being called from? One thing I might want to know. So I can pass arguments into the command to see where it came from. So here's how we're going to do that. So here, the execute function, as I said before, it can only receive one type of an argument. And that type is a constant JSON object. So if I want to receive arguments to my execute function, I'm just going to give it the variable name args and say that it can be anything, but what it will be is a constant JSON function. Then down here, where I was adding it to the command palette, I'm going to say args, and I'm going to pass in a constant JSON object. I'm going to pass in an object with the key of greeting and the value of hello from the command palette. And notice here in my say hello function, I'm also passing, in addition to the application I was passing before, I'm now passing in the args. So here in say hello, I'm receiving the args. I'm going to access the greeting attribute of that JSON object. If it does not exist, I'm going to get a null here. Now, one of the things I forgot to say over here, I could have also done it here with the launcher. I could have said args and passed in args from the launcher. But I chose not to because I want you to see what it's like with and without arguments. So I'm now going to pass in the greetings attribute to my hello world widget constructor. So here in this constructor, I'm going to accept a string called greeting. It's going to be either a string or null. If I get the string, I'm going to set the header inner text to that greeting. Otherwise, I'm going to set it to the default, what we had before, hello world from PyData. Okay, run the build, refresh the browser. Now, when I click here in the launcher, I get the default, hello world from PyData, but if I click over here from the command palette, I get hello from the command palette. Put those side by side so you can see them. Okay, finally the last part, which I'm actually going to break into 3 steps. We're going to create our own widget over here on the sidebar with several buttons to launch our widget in different ways. So I'm going to break it up. First, we're going to create a sidebar with buttons. Then we'll style it, and then we'll add event listers to the buttons. So we're going to declare a sidebar hello widget, extends widget. It's very similar to the other widget that we created. Call the super, give it an ID, give it a label, say closable equals true. We're going to add a different class because I want to style this one separately from the other one. Sidebar hello widget class is what I decided. Created 4 buttons, E, F, G, and H. Append the buttons to the body and append the body to this node. Then down here, outside of the actually still inside the activate function, everything's the same. But while I'm activating it, I want to activate this sidebar widget. So I'm going to make that a little bigger here so you can see. So I'm just declaring a sidebar widget. Now I'm calling the app shell add. Notice now I'm saying I want it on the left, not in the main area, but on the left side. And then I activate it. So now we run the build, we refresh the browser. Looks basically the same. Does anyone see what's different?
There is on the sidebar, it says hello world.
Right. Over here on the side. Over here on the side it says hello world. So these are all different sidebars here. You remember in the very beginning of the talk, I showed you how there was a file browser and the command thing. If I click here where it says hello world, I get this new widget that I created with the E, F, G, and H buttons.
It's a little cut off on the screen, our screen.
I don't know if I can change that. Maybe that's why you didn't say hello.
It's okay.
Yeah. All right, but you basically saw it, right? Everybody's Connecticut.
You have to seal the credit.
All right, so now we're going to style the sidebar widget. I'm not going to go into this. We'll save a little time. Basically, I just made the buttons bigger and gave it a similar background color as the others. Run the build, refresh the browser, and now the sidebar looks like this. E, F, G, and H buttons. Now, it's interesting to note, one thing I didn't do here to keep things simple, and also because I haven't done all the research to figure out how to do this. In theory, there are already classes in JupyterLab that I could have used to derive another sidebar widget. So it would have already probably had the same background color as the other sidebars. And not only that, if I did that and someone created their own theme extension, then because I derived from those classes, I would inherit the theme properly. But the way I did it now, I would not inherit the theme properly. So, if you're doing something really production quality, you wouldn't necessarily do it that way. All right, so now let's add event listeners to those buttons so they can actually do something. So here's my sidebar widget class. Instead of just creating 4 buttons, I created this record here. It's just a key value mapping of the E, F, G, and H. It's saying hello world in various languages. And then I'm going to loop through that mapping. For each element, I'm going to create a button. I'm going to set the inner text to the key. And then I'm going to add an event listener for clicking. An anonymous function that's now, remember, the command registry has an execute function. So I'm going to call the execute function, pass in the command ID, and I'm going to pass in the greeting from the value of this record over here. So I'm going to get a different greeting for each button. Now notice, in order to interact with the app, I now need the app in the constructor of my sidebar widget. And I also need the command ID, so I'm going to accept those. And then down here, where I was instantiating the sidebar widget, actually, I think I did this on the, so here, this is actually a better view of the class. Okay, here's that record I told you about, looping through, button, passing in the greeting, and appending the buttons to the body, and the body to the node. And then down here, where I instantiate the sidebar hello widget, I'm now passing in the app and the command ID. And we're still putting it on the left and so forth. run the build, refresh the browser, and now I have my 4 buttons. If I click the first one, I get hello world. If I click the F, I get bonjour le monde. G is aloha shaghel, I'm not sure how to pronounce that, and shalom olam. Okay, and that is basically the end of the tutorial. So if you want, you can open up your laptops. I'm going to show you where you can see the steps. There's a couple other things here I'm going to go through, maybe after you're working for a little bit. I'll go through the some of the documentation here on these other slides. But the first thing I want you to do, so here, if you go to my GitHub repository, so it's github.com, I don't know if you can see that. That's big enough, maybe I can make it a little bigger. github.com/Daniel Goldfarb /PYDJLX. So down here in the README, I broke this up into 2 parts. For step 0, follow the detailed sub-steps below. I'm going to show you that in a minute. And then for steps 1 through 7, again, we're just going to make a code change indicated in the code changes section, run the build, refresh the browser, and test. So here's step 0. All those commands that I ran, just step-by-step, conda create, conda activate, copier, cd into the directory, take a look at the files, run the git init. And so forth. And down here, here's the code changes for each step. So for example, if you click on step 1, it's going to take you to the GitHub diff for that code change. If I click on any of these other steps, again, it takes you to the GitHub diff. When I got to the slide where we created the widget, just put up that first widget that just said hello world. At that point, that's where you can build an application, right? You can use any browser-based technologies that you want. You can use React, you can use TypeScript, whatever you want there to build whatever application you want right there in that widget. So let me take a few minutes of your time and we'll go over some of the documentation that I listed here at the end of the slide. By the way, this GitHub repository that has the tutorial in it you can go down here where I created links to all the diffs, or alternatively, you can click here where it says 13 commits, and then if you just click on any of those commits, you'll see the diff that was for that step, and the commit usually indicates what the step was over here. But also in this repository, there's a file right here, slides.pdf. Those are the slides of the presentation I just gave you. And down here in the README, obviously, these are the specific steps written out. Anyway, so the last couple of slides, let me go into slideshow mode. And we'll go over a little bit of the documentation. So this one, the extension developer guide, is right here. There's a lot to read, all about how to develop extensions. I think having gone through my tutorial, it'll help you a bit to read this and understand it. Also within here is this idea of core tokens. These are the tokens. We saw some of these. For example, we saw, here is iLab shell. That's the shell we talked about. What did we see in here? We saw the launcher. Here's iLauncher. Right, so these are the core tokens. And I want to point out a couple of them that we didn't use that might be of interest to you. For example, this one, iLayout Restorer. This is a service that you can use so that you may have noticed if you're using JupyterLab and you have a notebook open, when you close JupyterLab and you reopen JupyterLab, the notebook is still open. So that's called the layout restore. So if you have your own extension and you want it also to be restored when JupyterLab stops and restarts, you can use this service. as a way of restoring the layout of your extension. Let's see what else is interesting here. Here's the command palette, which we use. What else? There's several in here. Let me see if I can find one of them. There were several in here called trackers. Like here's the editor tracker. There's the HTML viewer tracker, the image tracker. There's a notebook tracker. So the trackers are good if you want your extension, for example, suppose you wrote a spell check extension where you spell check everything in the notebook. You might want to have your extension use the notebook tracker to know every time a notebook was changed. And then you go back and spell check it again. So that's what the trackers do. So there's all kinds of services here available to you as an extension writer that you can use. Let's see, what else did I want to talk about? The front-end shell. This is the thing I was talking about before. When you're creating a widget, we used main, put it in the main area. We also used left. You can see there's top, there's menu for the menu items. There's left and right, down and bottom. I'm not sure what the difference is between down and bottom. I guess the bottom is the lower part with status bars and header. Now some of these, when we did left and we did main, all you have to do is add your widget. But some of them require that your widget or how you're adding it be a specific structure. For example, the menu requires a very, and the documentation will show you how, requires a very specific structure that you pass into it so that it knows what menu you want to put it in. There is another tutorial here in the JupyterLab documentation. This is called the random astronomy picture. There's a couple things you can learn from this that you didn't learn from mine, and there's a couple things in mine that you don't learn from this. One of the things, for example, in mine, every time you click the command, you got a new widget on the screen. One of the things they do here is they teach you, well, suppose I only want one. And if the person clicks it again, just bring it into focus. Bring it to the foreground, if in case it was in the background. So it teaches you how to do that. It also teaches you how to do inside JupyterLab promises, which is JavaScript for asynchronous communications, because this tutorial has you going off to some NASA website to get a random astronomy picture. Let's see, what else do we have here? And then there's this extension examples repository under JupyterLab. There's a lot of very simple code of different ways of doing it. Like here's a main menu example. If you want to know how can I put my extension into the main menu, you take a look at the code for this example. You basically have to clone it and build it to see how it works. There's not a lot of documentation within these examples. The code itself is the documentation. Here's the launcher. That's how I learned to use the iLauncher. And there's a few other things. Here you can learn how to do signals within your, to accept and send signals in your extension. What else do we have here? Here's the core, just a couple of core tokens that are interesting. As I mentioned before, there's the settings registry. You can have user settings for your extension, and the trackers I already mentioned, the layout restore I already mentioned. And that's it. And we are hiring a little bit if you're interested.